Hi there, Precalc. This is going to be problem number 43 that we covered from your book, section 1.6, 1.6, number 43, the radiator problem. We have a radiator that holds a total of 3.6 liters of coolant in it. It is currently has 40% water and it has 60% antifreeze. We need a 50% balance. So we're going to empty some out. This is the radiator beforehand. This is the radiator after. This is my second radiator. Same radiator, just after. And again, it is a 50% mixture. 50% each. So I'm going to write an expression. I'm going to walk this through. We actually have stuff leaving here and entering here. Whatever leaves here, okay, we'll say coolant leaves, we put water in. Those are the same things. The amount that a coolant that leaves is the same as the water that enters. So W is going to equal liters of water. Liters of water added. Note that that's exactly equal to the amount of coolant that currently left the radiator from the previous state. Well, if we want a 50% ratio, 50% of water, that means that the amount of water divided by the total amount in the radiator is going to equal 50%, or 1/2. So all I have to do is write an expression to model the amount of water in the radiator. Well, right now, the radiator is 40% filled with water. That means that 40% times its total amount of 3.6 liters is 1.44 liters of water. Now, there's some leaving, so I'm going to minus. And the amount that's leaving is 40%, or 0.4 times the amount of water. Now you may say, well, water isn't leaving, coolant's leaving. Remember, the amount of water added in and the amount of coolant leaving will be the same amounts. So I can replace that variable with W. So that represents the amount of coolant leaving. 40% of the amount of coolant leaving is water. 40% of the amount of coolant leaving is water. Plus, I'm adding stuff back in. Up here, I'm taking this water. Whoa, let's try it again. Taking this water and I'm putting it in, and it's 100% water. So I'm going to add W, 100% water, divided by the total amount. Well, there was 3.6, and we subtracted some coolant, and then we added some water. Remember, coolant and water are going to be the same amounts. The amount of coolant we drop out is equal to the water we put in. So that's a wash. It just goes away. They're the same things. So let's work with this equation, and we can solve it. Remember, it's equal to 1/2, 50%. It's equal to 50%. I'll write the equation out. 1.44, that represents the amount of water currently in the tank, minus 0.4 W plus W will be plus 0.6 W divided by 3.6 is equal to 1/2. Cross multiply. 3.6 is equal to 2.88 plus 1.2 W. I subtract. .72 is equal to 1.2 W. Divide both sides by 1.2. 0.6 is equal to W. 0.6 liters of water is what I need to add in. It is also the amount of coolant that I exit. So what I want to do is I want to bring this amount from 3.6 down to 3.0. Then I want to put 0.6 liters back in here. And that's how I figured it out. Really, the key to this problem is representing that 1/2 is going to be the amount of water divided by the total of the mixture. Hopefully that helps you. Good luck as you do the problems.